This is the series Common Counters to Evolution and How They Fail. This is part one. Evolution is just a theory. Before we begin, a fair use disclaimer. And as all YouTubers like to say, please like, comment, and subscribe. Also, please click the bell icon so that you get notifications when new videos are released. The anti-evolutionist claim that will be discussed in this video is evolution is just a theory. Notice how scientists always refer to it as the theory of evolution, never the law of evolution. That's because evolution is unsupported speculation. If evolution had been proven, it would have been promoted to a law and scientists would call it the law of evolution. Counters to the anti-evolutionist claim. A. In science, theories and laws are two different things and neither of them can become the other. Laws are descriptive and theories are explanatory. Laws, which often can be expressed mathematically, describe what happens under certain conditions, whereas theories explain how or why it happens. B. In science, theories are above laws. Theories are at a higher level of understanding. If one of them could be promoted to the other, they can't. But if they could, it would be laws that would be promoted to theories, not the other way around. And finally, C, it is not true that evolution is unsupported speculation. There is tons of valid, objective, positive evidence supporting evolution from various fields such as paleontology, comparative anatomy, comparative physiology, comparative embryology, comparative genomics, and biogeography, as well as from both field studies and lab experiments. However, even with all the evidence supporting the theory of evolution, it, just like other well-supported scientific theories, has not and cannot be proven true. Before we proceed, not so much about evolution. This first video in the series deals more with science in general than with evolution specifically. What is a scientific theory? Which provides more understanding in science, laws, or theories? Are facts more important or less important than hypotheses and theories? Can a theory become a law? Can science prove its theories? You already have the anti-evolutionist claim and three brief counters to it. If you're not interested in more details about those three counters, feel free to stop at this point, as if you needed my blessing. Okay, still before we proceed, an important distinction must be made between the meanings of the word theory in science versus in everyday usage. Here's a quote. The word theory is perhaps the most misunderstood word in science. In everyday usage, the synonym of theory is guess or hunch. Yet, according to the National Academy of Sciences, a theory is defined as a well-substantiated explanation of some aspect of the natural world that can incorporate facts, laws, inferences, and tested hypotheses. End quote. Scientific theories exist on a continuum ranging from somewhat speculative, newly proposed theories to very secure, well-established ones. The better supported a scientific theory is, the higher the degree of confidence scientists have that it is true, but they should never claim to have absolute certainty that it is true. Here's a quote from Richard Feynman. Scientific knowledge is a body of statements of varying degrees of certainty, some most unsure, some nearly sure, but none absolute certain. End quote. Even the most speculative of scientific theories must have good evidence supporting them, unlike the guesses or hunches people in everyday life think up and label as theories. Okay, with those preliminaries out of the way, we can now get into the greater details of the three counters to the anti-evolutionist claim. Okay, 1A, theories and laws are distinct. One cannot become the other. In science, theories and laws are two different things. Neither can become the other. Simply put, laws are descriptive and theories are explanatory. Laws, which often can be expressed mathematically, describe what happens under a certain set of conditions, whereas theories explain how or why it happens. I'd like to point out a few exceptions. The terms theory and law did not always carry their current meanings, and even today the terms may be misapplied sometimes. A few examples are as follows. A. In 1687, Isaac Newton published Principia, and in it he mentions his theory of gravity. He explicitly calls it a theory. But Newton didn't have any explanation at all for how gravity worked, so his usage of the word theory would not fit the modern usage for science. B. Around 1865, Gregor Mendel published 3 laws of heredity. However, they were not actual laws. For example, his law of independent assortment was refuted in the early 1900s by the discovery of genetic linkage. When I say refuted, I mean that a law should hold for all times and all places under all circumstances, and there are lots of circumstances where this supposed law does not hold. It's still a good guiding principle, but it's not a law. And then finally, C, today we can ask if string theory meets the definition of a scientific theory. For example, to the best of my knowledge, string theory is not falsifiable and makes no empirically testable predictions. To get an idea of how scientific theories and laws are different, those for gravity will be discussed. Let's consider Newton's law of universal gravitation, which he first published in 1687 in his work Principia. The law was expressed mathematically, and scientists could use it to calculate the force of attraction between any 2 objects in the universe. In this visual depiction, we're interested in 2 objects. Let's say this one is the Earth and this one is the Moon. Ignore the sizes. That would actually be important, but here we're not interested in sizes. So the 3 values we're interested in is the mass of the first object, m sub 1, the mass of the second object, m sub 2, and r, which is the distance between their centers of mass. That can be important. We're not interested in the distance between their surfaces, but between their centers of mass. Then we can come down here, use the equation that Isaac Newton gave us, plug in the values, and determine the gravitational force of attraction between those 2 objects. We multiply big G, we'll get back to that in a second, times the mass of the first object times the mass of the second object, and divide all that by the square of the distance between their centers of mass. So the gravitational force between 2 objects is directly proportional to the product of their masses and inversely proportional to the separating distance, the distance between their centers of mass. The only other kind of thing to remember here is that we're using big G, which is the gravitational constant, which should be theoretically the same anywhere in the universe. There's also a little g that varies by location. For example, at the surface of the Earth, little g is about 9.8 meters per second squared. That measures the acceleration that an object would experience if it was released right above the surface of the Earth. It would accelerate at a rate of 9.8 meters per second squared, neglecting air resistance. If you go to the Moon, little g is different. It has a lower value. Objects would accelerate more slowly at the surface of the Moon. And by the way, this little g is also why you weigh more on Earth than you do on the surface of the Moon, because little g is less there. Anyway, so that is what Isaac Newton gave us. But Newton had no explanation at all for how gravity worked. Gravity was just some mysterious, spooky force that supposedly reached out across hundreds of thousands of miles of empty space instantaneously and pulled the Moon, weighing trillions of tons, towards the Earth, or pulled other heavenly bodies towards each other, such as pulling the Earth towards the Sun. And by the way, the pull is in both directions because of Newton's third law of motion, but let's not get into that. When it came to explaining how gravity worked, Newton wrote, here's a quote, "I have not as yet been able to discover the reason for these properties of gravity from phenomena, and I do not feign hypotheses." In other words, Newton did not have a clue how gravity worked, but he still had a perfectly valid law. In 1915, Einstein published work on his general theory of relativity, which is basically a theory of gravity. Einstein's theory gave an explanation for gravity. Gravity is the curvature of 4-dimensional space-time itself. Objects, mass, energy, pressure, locally warp the 4D geometry of space-time in their vicinity, and other objects in motion then follow the straightest possible path, called a geodesic, through the deformations of space-time. Imagine a rubber sheet stretched taut, so it's flat. It's stretched in all directions equally and it's perfectly flat. A marble rolled on the sheet would follow a straight line. Now imagine putting something massive, such as a bowling ball, in the center of the rubber sheet. The bowling ball would deform the sheet in its vicinity with a degree of deformation decreasing with increasing distance from the bowling ball. Now rolling the same marble would result in it not following a straight path, but a curved one. So in this image, we've taken a bowling ball, supposedly, and put it in the center of the sheet, and you can see how it deforms it. The deformation is the largest close to the bowling ball, and then it decreases with increasing distance from the bowling ball. And now if you roll a marble, it won't follow a straight path, it'll follow a curved path. And basically, if there were no friction between the marble and the rubber sheet, and the marble had the correct initial velocity, it could orbit the bowling ball. Similar to how the bowling ball deforms the rubber sheet, the Earth's mass deforms space-time, with the amount of curvature trailing off with distance, and the Moon follows the straightest possible path through the curved space-time it encounters, and so orbits around the Earth. We could express this more simply as, the Earth tells space-time how to curve, and curved space-time tells the Moon how to move. In fact, a more general aphorism used to express the core idea of general relativity is, matter tells space-time how to curve, and curved space-time tells matter how to move. Thanks to Einstein, gravity was no longer a mysterious, spooky force that supposedly reached out across hundreds of thousands of miles of empty space instantaneously and pulled the Moon weighing trillions of tons towards the Earth. Instead, gravity was the local curvature of space-time dictating how objects, such as the Moon, move. The marching orders for the Moon do not come from a great distance away, the distant Earth. Instead, they originate from the Moon's immediate vicinity, from the local geometry of space-time. With Einstein's general theory of relativity, scientists had a much better understanding of gravity and how it worked than they had with Newton's law of universal gravitation, which, quote-unquote, merely described mathematically gravity's effects on bodies. And that brings up the next point. 1b, theories are above laws. Theories are at a higher level of understanding in science. In science, theories are at the highest level of understanding, even higher than laws. Newton's law of universal gravitation merely described gravity. Plug in some numbers, do the math, and out pops a number that describes how strongly the Earth and the Moon attract one another, and therefore how each one affects the motion of the other. But again, remember, Newton did not have any explanation for how it worked. On the other hand, Einstein's general theory of relativity explained gravity, and scientists had a much better understanding of gravity and how it worked. This brings up an interesting question. In science, what is the relative importance of hypotheses, theories, laws, and facts? This is going to be a long quote. Facts, hypotheses, laws, and theories. How do you think scientists would rank the terms facts, hypothesis, law, and theory? How would you list these four from most important to least? Most people list facts on top as the most important, followed by laws, then theories, with hypotheses being least important at the bottom. Most important, facts, followed by laws, and theories and hypotheses, and then least important. You may be surprised that scientists rearranged this list as follows. Most important, theories, followed by laws, followed by hypotheses, and finally followed by facts as least important. The source of that is the book Evolution versus Creationism, an introduction by Eugenie C. Scott. What is the ultimate goal of scientists? To discover laws? No, it is to formulate theories. Here's another quote. The ultimate goal of scientists is to formulate theories. A scientific theory provides explanations of observed natural phenomena and predictions that can be tested by further experiments. Theories often serve as a framework for organizing scientific knowledge. End quote. That comes from General Chemistry, 4th edition, Pearson Prentice Hall Publishing, 2005. As the above noted, scientific theories often serve as explanatory frameworks for organizing scientific knowledge. As noted below, too, here's another quote. A scientific theory actually represents a higher level of understanding than a fact. Facts are isolated observations or experimental results. You can accumulate hundreds or thousands of facts without really developing an understanding of the phenomenon you're trying to study. What theories do is place those facts into an explanatory framework that makes sense of them. More important, theories provide a pathway for further work. End quote. That's from Kenneth R. Miller of Darwin, Dover, and an Unintelligent Design from 2009. Because in science, theories are at a higher level of understanding than laws are, even if it were the case that one of them could be promoted to the other, they can't, it would be laws that would get promoted to theories, not the other way around. Therefore, it does not make sense to speak of evolution as just the theory, or to imply that evolution must be mere speculation because it is only a theory, as opposed to being a law. As a little aside here, consider QED, quantum electrodynamics, which is a relativistic quantum field theory and possibly the most stringently tested theory in science, and it is passed with flying colors. Now, don't ask me to explain the following. I have no degree of any kind in physics, but one of the most impressive results is the anomalous magnetic dipole moment of the electron, which I believe was experimentally confirmed to 12 decimal places. Without QED, the value should be 1, but when QED is used in the calculations, the result should be 1.00115965218073. An experimentation confirmed the latter far more precise value. I believe all last 12 digits, which are in red. QED is quite possibly the best verified theory in all of science ever, yet QED is still just a theory. Why? Well, because of 1A and 1B above. Theories and laws are distinct. One cannot become the other. It can't be so well supported that it stops being a theory and gets promoted to being a law. And again, theories are above laws. Theories are at a higher level of understanding. So you can't promote a theory up to a law. If you change a theory to a law, it would actually be kind of a demotion. Okay, and then 1C, evolution is not unsupported speculation. It is not true that evolution is unsupported speculation. There is tons of valid, objective, positive evidence supporting evolution from various fields, such as paleontology, comparative anatomy, comparative physiology, comparative embryology, comparative genomics, and biogeography, as well as from both field studies and lab experiments. Note, I could give a long presentation on just the evidence supporting evolution, but that is not the current topic, so I will not do so here. Perhaps in a future video series I will. You may ask, but if evolution really does have so much good evidence supporting it, then why isn't the theory of evolution considered to be proven? Because as a rule, the methods of science cannot prove anything. They can only disprove. In the negative case, the methods of science can disprove a scientific theory. But in the positive case, they cannot prove a scientific theory. They can only add additional support to it. Note, a supplementary video will discuss the above in more detail. In other words, the fact that the theory of evolution has not been proven is not a problem for it, because as a rule, no scientific theory has ever been proven and none ever will be. Yet, despite its limitations, science has a well-proven track record. Science works, and it works marvelously. So now we are to the recap section. Anti-evolutionists claim evolution is just a theory. Notice how scientists always refer to it as the theory of evolution, never the law of evolution. That's because evolution is unsupported speculation. If evolution had been proven, it would have been promoted to a law, and scientists will call it the law of evolution. The three counters to the anti-evolutionists' claim. A, in science, theories and laws are two different things, and neither of them can become the other. Laws are descriptive and theories are explanatory. Laws, which often can be expressed mathematically, describe what happens under certain conditions, whereas theories explain how or why it happens. B, in science, theories are above laws. Theories are at a higher level of understanding. If one of them could be promoted to the other, they can't, but if one could, It would be laws that would be promoted to theories, not the other way around. And finally, C, it is not true that evolution is unsupported speculation. There is tons of valid, objective, positive evidence supporting evolution from various fields, such as paleontology, comparative anatomy, comparative physiology, comparative embryology, comparative genomics, and biogeography, as well as from both field studies and lab experiments. However, even with all the evidence supporting the theory of evolution, it, just like other well-supported scientific theories, has not and cannot be proven true. That finishes the presentation, and thank you for watching.